Today's topic is special products of binomials, in particular the square of a binomial and the product of conjugates. We're going to focus on the square of a binomial first, and we're going to start with a numeric, not so much an algebraic example. If we were to take 5 plus 2 and square it, there are 4 ways we can go about this, and 3 of them are valid. The first thing you could do is follow the order of operations. Yes, do parentheses before powers or exponents. 5 plus 2 is 7. 7 squared is 49. I can certify that that's a correct answer. What else could we do? Well, if you like multiplying binomials, you could do something called double distribution. And that would look like this. I'm not recommending this. It's just another way to do it. And it's correct. We could go 5 times 5, 5 times 2, 2 times 5, and 2 times 2. Now, what you get is 25 plus 2 times 10 plus 4. Which we can compute easily enough. 25 here, 20 there, 25 plus 20 is 45, plus 4 is 49. So you can see we get the same answer. But I left it sort of expanded like this to motivate the next technique. The next technique would go like this. You follow the pattern advertised in this equation. So the pattern says, if I have a binomial, a plus b, and I'm trying to square it, I need to do 3 things. Square the a, later square the b. You can do that first or second or last, whatever you want. You just have to make sure all 3 of these terms are in your answer. So, squaring the a is 5 squared. Squaring the b is 2 squared, and the one in the middle often gets forgotten or neglected. It's the double, or twice, the product of the a and b terms in the binomial. So in this case, that's the double of 5 times 2. And you'll notice if you compute these, you get 25, just like we did here. You get 4, just like we did here. And you get 2 times 5 times 2 is 2 times 10, which is what we got here. Trust me, this makes 49. Now, I mentioned there's a 4th way. I don't think I'll show it to you. It's incorrect. It doesn't give the right answer. Sadly, though, a lot of people default to the incorrect technique. What is it? Well, not so much with number examples. With number examples for binomials, almost everybody would go this way. They'd add 5 and 2, get 7, square the 7. 7 times 7 is 49. That's the way to go. But for some reason, when we convert to algebraic expressions, such as this binomial x plus 8, and try to square it, very often students will square the x and square the 8 and forget about the stuff in the middle. In other words, they'll leave that out, and they'll just do 5 squared plus 2 squared. They'll come up with 29, and their answer will be 20 units too small. So you want to avoid that. Now let's talk about techniques for squaring algebraic binomials. I'm going to advertise 2 techniques. One is slow and steady and retrieves the answer, and I think everybody can do this. And then the second is sort of the speedy shortcut way. I can tell you which one I prefer, but first of all, let's look at the techniques. Squaring something means multiplying that thing by itself. Multiplying that thing by itself. So in other words, x plus 8 times x plus 8. And then in a video that I did previous to this one, we talked about the general idea of how to multiply binomials. We covered up this 8, and we multiplied through with this x, and we did it twice. So it was x times x, it was x times 8, and then it was stop, and shift our attention over to this 8. and then multiply through with it. So 8 times x and 8 times 8. Then total the columns. This first column has got x squared, the second column has got 16x, and the final column's got 64. Now, if you study this answer carefully, you can see how the three components of this trinomial were put together. X squared came from squaring the x. 64 came from squaring the 8. Don't forget about this stuff in the middle. It is the product of 8 and x. See, right here? And remember how I saw it twice? One came from here. That was the lower one. And one came from here. That was the upper one. Now that might help you understand the second technique. This is my favorite. It's the speedy way to do it. It's efficient. It's fast. Done correctly, it'll improve your life. Okay, how do we do it? Square the x, square the 8, but notice I left this big thing in the middle, a space for 8 times x doubled. And I get x squared, I get 16x, and I get 64. Okay, I'm going to do a variety of these problems. And these are all off of an assignment I'm making today for my students. I'm teaching remotely. And for them, I'm trying to think, I think it's called 7.3 practice. And I've just selected a few examples from their homework, and they get to do the ones that I don't cover. Let's try a minus 6 squared. You want to see it both ways? First, the slow way. The way that always works. And I have a lot of students. I've been doing this for, I don't know, almost 30 years. They prefer this method. Many of my students prefer this method because they can get the answer right. And when you get the answer right, you get the points. When you get the points, you get the grade. And when you get the grade, your parents are happy and you get your car keys back, right? Okay, the slow way. A times A. A times 6 with a minus sign. Notice I was ignoring this negative 6. But now, it's negative 6's turn. So negative 6 times A, and negative 6 times negative 6, which is a positive 36. So it turns out when you're squaring a binomial, these three terms of the trinomial always end up being, well, a square in the beginning, and it's positive, a square at the end. 6 times 6 is a square, 6 squared. And in the middle, you could get positive or negative, but it's always an even number because it's always the double of the 6 times A. That is the correct answer. Now let's take a look at the speedy way to do it. All right, you're going to need 3 things. Do the easy ones first. Square the A. Square the negative 6. That is literally negative 6 times negative 6. It's positive 36. Yep, you'll always get positive here, positive here. A perfect square, a perfect square. Don't forget the stuff in the middle. What is the stuff in the middle? Well, it's the product of 6 and A. Actually, it's negative 6 and A, which makes negative 6A. And it's doubled. All right, clean this up. This is a squared. 2 times 6 is 12, but it's a minus 12. And then we get a positive 36 at the end. I included this next example just because it's got all these minus signs here. And you may be surprised when we work it that the final answer has no minus signs in it. Now, I'm going to do this one just the slow way, and because I don't need to show both techniques for every problem. But here's how you would do it the slow and steady way. You would just remember that a square means multiply whatever you're squaring by a copy of that thing. All right, a squared means a times a. Negative 12 minus n squared means negative 12 minus n times negative 12 minus n. Okay, so we'll cover up this n And we'll multiply through here with this negative 12. Starting from here, negative 12 times negative 12 is positive 144. Positive. Negative 12 times negative n is positive 12n. We seem to get a lot of negative cancellation going on here, and it will continue. Watch this. Negative n times negative 12 is another positive 12. You can see this doubling occurring here. Negative n times negative n is positive n squared. So the final answer is 144 plus 24n plus n squared. Those of you who did the speedy method should have come up with the same thing. And let's move on. All right, this next one, let's do this one only the speedy way. So remember, when you're going to do it the speedy way, you're going to square the binomial. You have to remember that your answer is going to look like a trinomial. Here's the pattern again. The square of a, the square of b, but in the middle, do not neglect to multiply a and b and double it. Let's do that down here. First of all, squaring 2a means 2a times 2a. It's not 2a squared, it's 4a squared. Okay, squaring b, that's just b squared. And the product 2a times b can be written as 2ab, but you still have to double it. And on this problem, there are no minus signs. So it's 4a squared plus 4ab plus b squared. Pretty easy. And I can see I'm already 12 minutes into this, so I think I'll leave this next one to the student. Let's go on to the next page. We have a new pattern. This is called product of conjugates. We are multiplying two binomials together. And if you think about it, squaring a binomial is also multiplying two binomials together, because remember, a plus b squared means a plus b multiplied by itself. That's the slow, steady way to get the problem right. I demonstrated that multiple times, but this time we don't have two copies of a plus b being multiplied. We have an a plus b and an a minus b. So what's important here? These are binomials. They look almost entirely the same, but one of them has a plus and one of them has a minus. And it could be minus here and plus there. It doesn't really matter. They just have to look the same outside of the plus and the minus, that difference. And by the way, they must be different here. Okay, when you have all those conditions satisfied, you have binomials. And I'm going to do this one the slow way, and then I'm going to do this one the speedy way using this pattern up here. First, the slow way, 4x plus 1 times 4x minus 1. I mentioned several times that you have to multiply from here twice. So 4x times 4x is 16x squared. 4x times negative 1 is minus 4x. After having used this twice, you have to move over here and use this twice. 1 times 4 is plus 4x, and 1 times 1 is 1, but it's a minus 1. Now, the neat thing about multiplying conjugates is that the middle terms always cancel. So you're left with something like 16x squared minus 1. Does that remind you of this pattern up here? It should. We call this a difference of perfect squares. This is the square of 4x, and this is the square of 1. Okay, now for the speedy method. How to get to that same answer just a little bit faster. Well, in the speedy method, you first check to make sure you have conjugates. And when you know that you've got conjugates, you can rely on this notion that these middle two terms are going to cancel. So you just dismiss them. You just multiply these, which, by the way, is equivalent to squaring that. And then you multiply these. But don't forget the minus sign. 1 times 1 is 1, and you're done. Okay, let's do the next one. But let's do it only the efficient way. 8 plus 3a times 8 minus 3a. The efficient way to do this is to multiply 8 times 8, that's 8 squared, So you can write it like this, or you can write it like this, your choice. And then multiply 3a times 3a, which can be written like this, or it can be written like this. All you have to do is remember to put minus in the middle, and you're on the way to success. I'm really not doing these two problems differently. It's really just the same thing. I get 64 here, and I get 9a squared there, and don't forget it's minus in the middle. Yeah, that's an a with a long tail. Okay. I like this speedy method so much, I think I'm going to demonstrate it. No, I'll do this problem, both methods on this problem, okay? First of all, I'm going to multiply 7m times 7m, get 49m squared. I'm going to multiply 7m times negative 8n and get negative 56mn. Then I'm going to move over to 8n and multiply through that. I'm going to get 56 again, but this time it's a plus 56, and it still has the m and the n. So these are still like terms right here, and they're still perfect opposites. They're going to cancel. Conjugates always cancel middle terms. 8 times 8 is 64n squared. And it's minus. And these cancel. So you're left with 49m squared minus 64n squared. And what was the speedy way to do that? Well, just multiply the first two, 7 times 7 and m times m. Then multiply the last two, 8 times 8 is 64, n times n is n squared. Put a minus in the middle, and you're done. All right, this problem includes conjugates. I know these are both negative, but they look the same, don't they? And here, these are both 4s, except this is plus and this is minus, so that falls into the conjugate family. I think I'll skip down to this last one, though, because it's got r cubed in it. Don't be intimidated. These are the same, and these are the same. And this is minus and this is plus. So in fact, we do have conjugates. Now, I'm going to do this one, I think, just the speedy way. I'm going to multiply these two. That's r cubed times r cubed. And I'm going to multiply these two. That's 6t to the 4th times 6t to the 4th. Don't forget to put minus in the middle. There always is. Okay, multiplying two powers that have the same base, you just add the exponents together. It's not 3 times 3, it's 3 plus 3. That's r to the 6th. And over here I go 6 times 6 and get 36. T to the 4th times t to the 4th would get you up to t to the 8th. Yes, the power goes up when you're multiplying two powers that have the same base. Add the exponents to get an 8, and don't forget to put minus in the middle. Okay, if you've heard enough, you can turn the video off, but there's some fun things you can do with conjugates. You might try this at a party sometime if you're really bored and trying to make some new friends. Is it's really quick and easy way to multiply 33 times 27, only because these are both very, very close to 30. They're not just close to 30, they're equidistant from 30. This is 3 bigger than 30, and this is 3 smaller than 30. So the way to do this, and I think quite a few of you can do this in your heads, is just work it like this. Those are conjugates. So you multiply those. 30 times 30 is 900. And you multiply these. 3 times 3 is 9. Don't forget to put the minus in the middle. And then, yeah, you have to know that 900 minus 9 makes 891. Can you do all that in your head? Well, if you can, it's a fun way to make it look like you're very good at calculating complex things. Now, this next one is not a conjugate problem because we're squaring something. But if you go back to what we did at the beginning of the video, this relates to something like 40 plus 2. This is a binomial squared. And the speedy way to do this would be to square the 40, which is 40 times 40. Square the 2, which is 2 squared. And then don't forget that in the middle, you have to multiply these two together and double. 2 times 40, bless you, and double it. I don't know. Can you do all that in your head? This is 160. Okay. No, we need another 0 on there. Excuse me. That's 1600. This is 2 times 80. This is 160. And then this is 4. And you add all those up, and you get 1,764, which is the square of 42. Pretty fun. All right, last one. 29 squared. 20 is very close to 30. So you're going to write 30 minus 1, and you're going to square it according to the pattern of multiplying a binomial by itself, squaring a binomial. You'll have 3 things. Everybody remembers this one, 30 squared. 30 times 30, that's 900. Everybody remembers this one, 1 squared. 1 times 1 is 1, and it's a plus. But you might get a minus here. In fact, you will, because why? Well, this is 30 times negative 1. And don't forget to do what? Double it. That's right. So, let's see if we can add all this up. 30 times negative 1 is negative 30. 2 times negative 30 is negative 60. I have 900 minus 60 plus 1. This is 900 minus 60 is 840 plus 1 is 841. Well, I hope you learned something. My name's Eric. Have a nice day.